Good evening, guys. It is night 4 of Lambda School's Introduction to Web Development. So we are almost halfway through this course. I'm Diandra Moss, your instructor, and tonight we're going to be continuing to learn all about JavaScript. So earlier this week, we learned about HTML, CSS, and then started on JavaScript last night on Monday. And so we'll be continuing on with JavaScript for the rest of this course. So all of next week, we'll be talking about JavaScript. So before we get into our topic for tonight, which is control flow, I want to talk to you a little bit about Lambda School. As you know, Lambda School is a 6-month, entirely online computer science immersive that teaches web development. And it is a really cool course because not only can you take it from anywhere in the world, but you also can take it with paying zero upfront. So I know I've talked about this before, but I'll talk about it every single night because I just love our deferred tuition model. That means that you can start and complete this program without paying a single dollar of tuition. It's only after you are hired that you'll start paying back your tuition in proportion to whatever you end up making. But the thing I want to focus on tonight isn't the tuition model. It's actually what you do while you're in Lambda School. So now that you've been exposed to a few different languages, we can talk in a little more detail about what you'll actually be learning inside of Lambda School's curriculum. So as mentioned, you'll be doing all sorts of web development topics, front end, back end, but what does that really look like? Well, you'll be doing front end topics such as HTML and CSS, but HTML and CSS aren't necessarily as simple as just those languages, especially CSS. It turns out that CSS preprocessors like less are a really important part of how CSS is run. And if you don't know the term preprocessor, I'm not going to explain it in detail, but essentially it's something that just lets you write your CSS code in a little bit more of a sophisticated way. We'll also briefly touch upon some CSS frameworks that you might use, like Bootstrap. These frameworks are additional code models that go on top of the language to make life even easier. So in that way, you'll learn how to do all the things we discussed the first 2 nights in far more detail with a few extra tools under your belt. As far as the JavaScript portion goes, the front-end JavaScript will also utilize a framework. Frameworks are extremely common in the industry. And once again, if you don't know the term framework, that's all right, but you'll hear it a lot. It's essentially just an add-on to a language. So a front-end framework that we love is called React, and that's the one that we teach in Lambda School. As well as front-end JavaScript, you'll be learning back-end JavaScript. So using JavaScript that is designed to handle all the secret data behind the scenes-y things. And within that, you'll be working in a JavaScript environment called Node. And I know I'm throwing out a lot of random terms. You don't need to know what all these are, but if you do know what they are and you're curious about what we'd be learning, wanted to let you know. Within the context of that, you'll also be exploring some database topics and looking at SQL and NoSQL databases. And that is the entire stack of web development. So you'll be learning how to build websites and web apps from the ground up. And then finally, beyond just topics of web development, we want to round you out as developers. So we do a little section on Python, we do a section on C, and we use these languages to teach you about some data, some cool data stuff, and then also teaching you some algorithms and computer science topics. So you come out of this course with a pretty incredible education. We do focus heavily on the practical day-to-day stuff, the how to build the web apps, the front end, the back end, the frameworks, all that stuff that you'll be using on the job. But we also want to round it out with more computer science topics. So those final topics I mentioned are more the kind of thing you'd see in a computer science degree. So we give you a little taste of that as well. So at the end of the day, you really know what you're talking about. You know the practical skills, and you also have a little bit of the more theoretical background. And I'm sorry, I have really bad allergies today, so I apologize for sniffling. I might have to go sneak off and grab a box of tissues if this gets worse. But luckily, you're all far away from me, so if it turns out it's a cold, there's no risk of contagion. But anyways, that's all I wanted to share with you about Lambda School. And on that note, I think that we will move on to our topic for tonight. So I'll do a little JavaScript review of a few things we saw last night, and then we will talk about control flow. And I might just quickly sneak off and find a box of tissues so you don't have to listen to me sniffle for the next hour. So give me 1 second. You guys can contemplate the word control or the words control flow, and I will be right back. Okay. All right, so let's do a little review. I want to just review some of the core topics that we learned last night. So for starters, we learned all about data types in JavaScript. There are definitely some we didn't touch on last night, but in chat, can you guys throw out some of the types in JavaScript that we learned last night? Strings. So strings are chunks of text, like this word strings. We learned numbers. Yes, we learned undefined, null, and the last one I see is Booleans. Awesome. So you guys got all 5 of them. We did also briefly talk about functions, but we didn't explore that one too much, so I think that's fine. We'll go over functions in a great amount of detail on, not tomorrow, tomorrow's Friday, on Monday. So strings are chunks of characters. They could be words, sentences, they could be random gibberish, they could even be the empty string. We didn't really talk about this last night, but if you just do 2 quotes next to each other, that's still a string. It's just an empty string. Numbers are also quite versatile. Whole numbers, negative numbers, fractions. You saw that pi is an option as well. Undefined and null are these 2 kind of weird things that we have that both signify missing data. So kind of like staring into the void when you have undefined and null. And then finally we have Booleans. Booleans are this magical little reflection of the secret world of computers. So we don't have to deal with binary at any point in this class, in this intro class. You do get to do a little binary section in the main curriculum, which I think is super cool because I'm a nerd. But there is this little insight into the binary world of ones and zeros with the data type of Booleans. And Booleans are classified as true or false, which you could think of as being on or off. So these are the 5 basic or primitive data types that you might be working with in JavaScript. And on their own, they don't really do much. When we just create a string, that line of code is a little bit useless. So what are the things we can do with these data types? Well, the most basic and common one would be to store it somewhere in memory. That is called declaring a variable. So we create our variable name or a label to look it up later, like, I can't use class. Class is actually great opportunity to show you. So I couldn't name a variable class because class is actually a reserved word in JavaScript. So class is, it glows in blue, it's a keyword. That means we can't use it a variable name. So we could say class topic instead and set that equal to control flow. So now I have not only created a string, but I've saved it. I've stored it in memory so I can look it up later. And because I used the keyword const, I couldn't on Monday change the class topic to functions. This would give me an error because I've used the constant keyword, which means that this label is bound to this particular value. If I wanted to be able to change the class topic, which is good because that would suck if you guys had to learn about control flow 4 more times next week, I might use the word let instead. Let is a little bit more flexible word for variable declaration. It binds our label to our value for now, but if we decide that class topic should point at a different value, we can now swap that. So you could think about this as being this arrow that points at control flow stored in memory. And then on line 4, we actually move where the arrow goes, so it's pointing at something else. So for a minute, control flow is still in memory somewhere, just disembodied. And then there's something called garbage collection that will come by and sweep it away. So you don't need to know about garbage collection, but it's kind of this interesting thing that prevents us from having a bunch of disembodied values all taking up memory in our computers. So it's good. So that's declaring variables. And the last thing I wanted to review with you guys, which was a very pertinent topic, and you guys got to play with a lot on the homework, is this idea of code resolution and side effects. So code resolution is extremely important. It's what makes code so dynamic. It's this idea that different lines of code resolve to some value, so that means that they could be a building block for a larger and larger line of code. So for example, 3 resolves to 3. Kind of obvious, but what that means is that we can use it in a larger expression, like 3 plus 4, which resolves to 7, which means we could use it in an even larger expression, like math dot, let's do math dot round. I'll make it just a little more interesting. So 3 plus 4.2 can be used in this even larger expression. And math dot round also resolves to something, which we can see in Replit in green, which means we could use it in an even larger expression, like storing it into a variable. Now this, you can pretty much do this indefinitely. As long as you keep creating expressions that have a resolution, you can keep building them on and on and on. And you can come up with some pretty convoluted lines of code in this way. I recommend at some point limiting it just so your code is readable. But something like this, something like this is totally reasonable. So then we see that finally this whole line of code, this no longer resolves to anything. That means that we're done. We couldn't use this entire line here to build another expression. We couldn't throw this whole thing in parentheses and try and, add another number onto it. We'd get an error. So at some point, you might hit the point where you've written something that does not resolve to anything, which means that you have to be done. You have to move on to the next line. But lines of code that don't have a resolution aren't necessarily useless because they might have a side effect. Can you guys in chat define for me what a side effect is and give me a few examples of it? Changed memory, yeah. So that's exactly the side effect that this line has. So whenever something is stored in memory, a new variable is created or reassigned, that would be an example of a side effect. Something somewhere else outside of just your little lines of code has changed. Displaying something on the console is another example of a side effect. Changing the color of the background of your website, great example of another side effect. So something outside, so think of code resolution as being building blocks that you can use within your code base, whereas side effects are effects that are happening elsewhere. And one example that we didn't really talk about is that, well, I won't get into that. That's a little too convoluted. But we'll keep having a conversation about this idea of side effects as we move on and see more interesting examples. So let's see. Yeah, that's everything I wanted to review. So moving on to our next topic here, let's talk about the if-else statement. This is kind of the first topic in our control flow series. So to start out, I haven't defined the term control flow at all, but some of you guys might already know this. What is control flow? Can anyone try and define it? If you know, or if you want to take a wild guess, go for it. Manipulating the logical flow. Nice. The flow of which code block runs, a way to keep coding, the order in which the code runs. That's a really good definition. So think about your programming language is running from top to bottom. There are a few little exceptions to this, but for the most part, you're pretty safe if you assume your code runs top to bottom. And not only does it run top to bottom, unless it hits some sort of syntax error, every line of code will be read and executed. And in some ways that's nice because you have a nice orderly system, but it's also not nice because it really limits the types of things we can do. So interesting, sophisticated program shouldn't run all the same lines of code every single time. It should actually react to external factors. It should react to the user input. It should react to, it might react to the weather. It might react to the location you're in. It might react to the time of day you're using the app. So let's say that we had, actually, here's an interesting example. So phones these days, at least I know my iPhone does this, will actually change the brightness of my screen depending on what time of day it is. So let's kind of mock out this scenario here. So let's say that we have a variable called screen brightness. I'll just call it brightness. And it'll be out of 100. So if this is like full brightness. And we might be changing this. And then we also have a variable called time. And there are better ways of storing time in JavaScript, but we're going to kind of mock it out right now. So we're just going to make time be a number. So let time equal, let's say, we'll do it in military time down to the minute. So right now it's 5:16. So that's, can I do simple math? 17:16. So there is our time and there is our brightness. So the thing is that this brightness variable, maybe in the evening, it should be 100. But, you know, a little later in the evening, it should start to pare down a little bit to kind of psychologically get me ready, or whoever our user is, get them ready for sleeping. So, and maybe even in the evening, it should already be down to, let's say, 75%. So we don't want to just assign brightness off the cuff. We want to actually change what the value of brightness is depending on this time. And so that would be an example of when we would use control flow, because our code is going to do something slightly different depending on an external factor. And I just want to mention that I've hard coded in the time here. And for just the purposes of this lesson, I'll be changing it. But what would really happen is you'd actually use a more advanced line of JavaScript to actually check what time it is on the user's computer. That's completely valid. That's something we're allowed to do with the magic of JavaScript. So let me show you the if statement. So we might say if it is, we're going to make this really simple. Actually, I feel like this example is way too complicated for your first if statement, but I'm just going to go with it because I already put it up. So we'll say if time is less than, let's say we want to really dim this thing at 8 o'clock, which is going to be 20 o'clock, right? Or yeah. So if time is less than that, then we might set brightness to 75%. And we'll start with this undefined. So you can always declare variables with let and not define them off the cuff if you think you're going to define them later. So what's happening here? Well, we're saying that if it's before 8 o'clock, we want brightness to be at 75%. And we see that it worked. Brightness was set to 75% because this condition in our if statement was true. But if we change this to being later at night, that is not a valid time. There we go. Then brightness is not defined, so which is not very sophisticated either. But let's, you know, I might scrap this brightness example. I feel like it's doing more harm than good, but maybe I'll keep it for later. So let's make it really simple instead. I like to use this raining example. So we'll do let raining equal true. So if raining, not log, bring an umbrella. All right. So what we're saying here is only run line 6 if raining is true, if it is true that it is raining. So if we switch it to false, notice that nothing appears on the console here. That's because line 6 has never run. And that's the idea of an if statement or an if-else statement, which we'll explore in a minute. It's a conditional. It's saying you start out with the keyword if, then a set of parentheses that define our condition, and inside that should be some sort of Boolean value. Then we use 2 curly brackets, and this starts our if block. And anything in our if block is optional. So it doesn't just have to be one line of code in here. It could be bring an umbrella, wear rain boots, We don't want these all tabbed over though. I'm gonna be lazy, don't catch a cold. Okay, so none of these console logs run because raining is currently set to false. But if we change it to true, now all of them run. So everything inside the curly brackets, inside the if block, will run when the condition is true. And just like in my failed brightness example, this wouldn't actually be hard-coded in. It'd be coming from an external source that would be querying some sort of weather database to tell you if it actually is raining and updating this app in real time. Another thing I want to briefly mention just in terms of style and white space is, remember in HTML and CSS how we like to tab over to signify that something was nested in something else? The same thing goes in JavaScript. Whenever we start an if block or any other type of block, you want to tab all the code over so that you can clearly and visually see that all of these lines of code exist within our if block. Excuse me. So yeah, that's how you write an if statement. So now for the first time, you have some optional lines of code here. Sometimes you want a default. So we know what the behavior is if it's raining. We want to know what the behavior is if it's not raining. So you could always write a new if statement, if not raining, remember our not operator, and then we could do console log, go to the park. What else do you do when it's not raining? Go for a walk, what a bike ride, etc. So now when we switch this to false, this if statement would take care of it. As it were, this is a really common scenario where we want some sort of default. So there's a shorthand way of doing this. This second if block is not necessary and not recommended. So to accomplish exactly the same thing as having a second if statement that says not raining, we can just use a single word called else. So else does the exact same thing that the code I just deleted did. It says, if this condition is not true, run this instead. So a good rule of thumb with an if-else statement is that either all of the code in the if statement will run or all of the code in the else statement will run, but never both. It's impossible. It is, sorry guys. It is logically impossible for both the if and the else statement to run. If you manage to get that to happen, you have just created a logical fallacy and you're probably about to be plunged into some sort of like Alice in Wonderland mysterious place. So, but I've never had that happen. And if anyone would break the rules of logic, it would be me. So I think you're safe. So that's if-else statements. That is the basics of how you do them. And as far as, I just see a quick question about, do you have to put a console log in here? Absolutely not. I'm just putting a console log in here because it's the clearest way for you to see that things are happening. But this could be anything. I could be writing x equals 3, plus y equals x plus 10. I could be doing anything inside of here. The point is that these lines will not run or only will run when this is true. And these lines will only run when that's false. But this question of just console logging and this example of creating some variables in here actually is an excellent lead-in into my next topic, which is something called scope. So now that you've seen your first example of a block, we have to talk a little bit about scope. And scope is one of those more advanced topics that is something that you could skim over to learn the basics, but I like to at least introduce you to the idea because I want you guys thinking about this in a sophisticated way. Scope is one of the big differences in JavaScript between someone who's just going through the motions and writing code versus someone who's really thinking like a programmer. So scope is basically our environment. So you could think about everything. By default, we're in something that's called the global scope. So whenever we write just regular old lines of code outside of a pair of curly brackets, we are in the global scope. And think about this as being like public property. This is like a public library. Anyone can come in and use this variable because it exists in the global scope. So we know that if I try to use raining down here on line 15, it's accessible. I see the value right there. I can't use it above just because it hasn't been declared yet, or it hasn't been assigned yet. It's actually, there's a weird thing called hoisting. Not going to talk about hoisting. If you guys want to hear about hoisting, ask me at the end. But basically, you can think about it as this variable is available anywhere. If you want it to actually be assigned to the value you want, make sure it's below the variable declaration statements, but it is public property. Anyone can use it. So we can use it anywhere. Inside of the if block, we have something called block scope. And inside of the else block, we also have block scope. This is a little more secure. This is more like the bookshelf inside of your house. So let's actually go back to the global scope for a second. So because raining, the variable raining, is public property, we can use it anywhere in public in the global scope, but we could also use it inside of the block scope. Just like you can take a public library book and bring it into your home. That's allowed. So if we console logged raining in here, oh, let's change it to true. That's allowed. We can use the variable raining inside of our block scope because it's a global scope variable. However, the rules are different for variables declared within block scope. So as I said, think about these variables X and Y as being more like books on the bookshelf in your home. So as long as you're within your home, thinking about your home as being between the curly brackets, you can do whatever you want with them. We could console log Y or X, we could console log Y. We've already used X to create Y. That all works. So these things are totally fair game as long as you're within the scope. But you're not allowed to pull them back out. So at the bottom here, if I tried to console log X, I would get reference error, X is not defined. And that's because X and Y will only exist between the two curly brackets. Once we're out of the curly brackets, they're cleared. It's like they never existed. Remember that garbage collection thing? They're going to be taken away. So that's how scope works in a nutshell. I will say that if you use the keyword var, this rule isn't exactly the same, but we don't like the word var. In fact, one of the reasons we love const and let is because of this rule. This rule actually works in our favor. It is one more thing to keep track of at the beginning, but it's good for us. It means that we can keep our concerns separated. It means that we don't have to worry about having to come up with a million variable names because we used X up here and then we have to come up with some new variable names to use an else and some new variable names here. So the scope thing is good. So the scope thing isn't necessarily the most important thing. Don't get too hung up on it. It's just an idea I want you to start mulling over. It's a term I want you to get used to hearing. And I'll present it in a few other contexts all throughout next week and even later in tonight's lecture. So I just want you guys to start marinating in this idea of scope. And yes, to answer a question I see pop up, I'm totally enabling you guys for asking questions in the chat. It's not a good habit, but the if scope and the else scope are different. A good rule of thumb is that whenever you see a pair of curly brackets, there's probably a new scope. So that's one scope, that's another. All right, so that is scope for you. What are we going to talk about next? Ooh, comparison operators. I showed you a few cool things. Let's actually, oh darn. I copied and pasted that time example, but now it's gone. Let's do this example. So we're gonna do a bouncer app. The bouncer has to keep people under 18 out of the dance club and people under 21 out of the nightclub. So if we're making a bouncer app, we need to probably do an if-else statement, but we're going to be doing something a little more interesting inside of our condition. And this is what I started to do earlier. So one thing that we can do with numbers, and actually other things too, is compare them. So we might say if age is less than 18, or we'll just say, yeah, it's an 18, no dance club. else. All right, so because age is set to 19 right now, this person is allowed in the dance club. But if we flipped it down to 16, they would not be allowed. Yes, you can dance if you want to. That's what I should change this to. Okay. Way better than what I thought of. Okay. So if we change this to 16, now they must leave their friends behind because they are not permitted in the dance club. So, anyways, what we have done in this conditional here is instead of just putting in a pure Boolean, we've put in a comparison. And I think you guys did get a chance to play with comparisons a little bit in the homework last night. But it's just this idea of you can form a new expression by comparing values to each other. So of course you can compare numbers with greater than, less than. You could also do less than or equal to. You can also compare non-numbers. If you want to compare strings, you can do that. It is alphabetical, but you have to be careful because with comparing strings, because the rules change if they're lowercase versus uppercase. So there's some unintuitive stuff about comparing strings. So keep an eye out for that. And then another comparison you might do is checking if things are equal. So it's very tempting to write this line of code. It seems logical, right? If ABC is equal to DEF, yet if we run this, we get invalid left-hand sign in assignment, invalid left-hand side in assignment expression. What does that mean? It means that the single equal sign is only used for one thing in JavaScript, and that's assigning variables. It is not used for comparison. Never use the single equal sign for comparison. If you try, you'll probably see this. Instead, you can use the double equals. The double equals is, and I know we have random console logs up here, but just keep an eye on the green for now. The double equals compares things, but it's a little loose. So for example, string 12 and number 12 are considered double equal. It doesn't really care about type. So once again, you have to be careful with this double equal sign. It might do some unexpected things. And because that's the case, and because you guys are new to JavaScript, I'm going to recommend you stay away from the double equals for now and stick with triple equals. Triple equals is a true equal. So triple equals says these are not equivalent because, as we know, one is a string and one is a number. So triple equal comparison is the kind of thing you might see in a if-else statement condition as well. The other thing you might see is not equals. So you just throw that not operator on the beginning, and this will say, is the string 12 not equal to the number 12? So that's something you might want to use as well. So those are the different ways that we can compare. And they're really useful because if-else statements tend to be a bit more interesting when you have something dynamic like a comparison in the equal sign. All right, let's come back to this dance club example. So, so what if the dance club has alcohol? That's another condition, right? So now we have a few different options because if you're under 18, you can't come in at all. If you're 18 to 20, then you can come in, but you can't get drinks. But if you're 21 or older, then you're permitted, you can get drinks, all's good, you know, party, party, party. So if-else statements only work for two options. It's an either or. But that doesn't mean that we're out of luck if we want 3 options or 4 options. So we might say, else if age is less than 21. And then finally we say else. I don't think I can use a safety dance lyric for this one unless someone thinks of something clever, but we'll say you can drink if you want to. Okay, so what have I done here? I've started with my if statement, if age is less than 18. Then I've done an else if statement, which is like a second option. So my second option is if age is less than 21. And in that case, you can dance. And then finally, I have my fallback option, which is that you can actually drink. So we see that the value, the console log is going to change based on what I put into here. Okay, so I have a question for you guys. In my second condition, I've said age is less than 21, but wouldn't a 16-year-old, if we put this back to 16, a 16-year-old is less than 21. So why is this condition not triggering on age 16? Does anyone want to take a guess, or does anyone know? Priority, it satisfies the first one only. Control flow, the first one overrules. Yeah, so I think you guys are you're right on track, which is that what it will do is it will check the first one. If the first one is true, it will run this block and then it will be done. So if the first one happens to be true, you'll never ever even see the second one. So in that way, we can write slightly simpler statements, because we know that if we've even gotten to this point, we're already positive that this person is not under 18. So in that case, we don't have to add extra conditions in here. So just like the if-else statement, it's only possible that one of these options will run. There could never be multiple options that run because of the way the logic is set up. So there's an else if statement. That's what you want to use if you have more than one scenario that you're trying to play out with control flow. What would happen if the first condition were age is less than 21? Interesting question. So if that were the case, then for a 20-year-old, it would never get to this statement, ever, ever. Because for a 21-year-old, it'd say you must leave your friends behind, which means you have to leave. So this is not the way you would want to write this code, because you'd never get to the second condition. Okay, so let's go ahead and do, actually, if we wanted to think about this dance club thing, if this rule were not true, we'd have to use a logical operator. We'd have to say if age is greater than or equal to 18 and age is less than 21. You remember and that I briefly introduced you to last night? That's saying that both of these conditions have to be true. So, and this is a little convoluted example, so I'm actually going to wipe the slate clean so that we can explore some ands and some ors. So let's do a little review of logical operators from last night, because you will be having to work with them a bunch today. So logical operators. Okay, so logical operators, we have our not, we have our or, and we have our and. And I'm gonna set something up. Actually, let's say. Okay, so we're gonna do a little example about trying to go to the potluck. But before we get into that, who can remind me what not, or, and do? All right, not flips the Boolean value. Awesome. True becomes false, false becomes true. What about or? It is the logical or. Either one, yep. So either Boolean, how do I phrase this? Let's say at least one value must be true. And what about and? Both need to be true. Cool. So let's move on to our potluck example. So if you want to be a good guest at a potluck, you should probably make food or bring drinks or possibly both. So this would be a case where the or statement would be great. So you can say, we'll do good potluck guest equals made food or brought drinks. All right, so right now, are we a good potluck guest based on the values I have up here? Yes, yes, we are, because we made food. And so we really, that'd be great if we did both, but as long as we did one or the other, they're not going to frown when we walk in the door, unless we bring 8 friends. That's the other potluck faux pas. So made food, true. So this is going to be true. So because at least one of these were true, this was set equal to true as well. If we did both, that's totally fine. If we brought drinks, but didn't make food, that's cool too. Maybe we're terrible cooks, in which case we shouldn't make food. Maybe you tried to make a pie using my primitive pie recipe from night 2 and discovered that it was insufficient. So you're like, ooh, gotta throw this away and then bring drinks. Still fine. But if we don't do either, if we just show up to freeload, then it's gonna be set to false. So if we did not make food, we did not bring drinks, we are not a good potluck guest. So what if we wanted to change this to bad potluck guest? What could we do to our code up here to make this variable equivalent to if we're a bad potluck guest or not? Not, yeah. And this is important. There are a couple different ways we could do it. But one way is that we could not the entire expression. So we know that this in parentheses says if we're a good potluck guest, so we'll resolve the whole thing and then flip it. So now we see true, we are a bad potluck guest. And I see someone else mentioning that the other way to do it would be if we did not make food and we did not bring drinks, also valid, logically equivalent to each other. So we can see that we can mix and match these ors and these ands. So let's do an and example where we don't have nots thrown all over the place. Let's do, let me think of a good example. Oh, I'm gonna flip over to DMV examples are great for this. I had to go to the DMV last month and I realized that the DMV and all bureaucracy is like an ocean of logical operators, because it's like you have to bring your passport or your birth certificate, or your, state ID and social security number. So next time you have to do some obnoxious bureaucratic task, take the opportunity to translate it into some logical statements. It might make things a little less tedious, but yeah. So there you go. So I think now I'm trying to remember what I actually needed. I think I needed a passport and to pay my fee and to proof of residency or something to get my Arizona ID. And I'm totally pseudocoding here. So let's say I got my passports, I paid my fee, but I totally forgot my paperwork. So that's bad, right? If I want to get my ID, that's going to be passport and fee and paperwork. So right now I am not going to be able to get that ID. But luckily let's say the DMV then has an extra blank copy on hand and I fill it out in the uncomfortable weird little chairs they have. So then we can switch paperwork to true. And then now we see that this became true because all of my conditions were true. So we're good to go. And as you've hopefully extrapolated, we can, ands and ors are not just for 2 statements. We can and as many things as we want together. We can or as many things as we want together. In the case of ands, it just needs to be that they're all true. In the cases of ors, we just need one to be true, no matter how many we have all together. So there you go, a little review of these logical operators. You'll have a lot of time to practice them on the homework tonight. The next thing I want to introduce you to, the next weird side of Booleans in JavaScript, is called truthiness and falsiness. Is it? Yeah, I think it's spelled like that. So let's do let condition, if condition something. So I haven't assigned my condition yet, but here's just kind of a basic setup of an if-else statement. We know that if the condition's true, it's going to log true. If it's false, it's going to log false. If we set this to true, it logs true. If we set it to false, it logs false. But we haven't really explored what happens when we set this to a non-Boolean. So what do you think is going to happen if I set this to the string true? Any guesses? We say it's going to go true. Turns out that's right, because true is, the string true is something called truthy. What if we set it to the string false? There's no tricking you guys. Yep, the string false will also be true. So, okay, some of you guys are probably scratching your heads. Let me explain the rules of truthy and falsy. The truthy and falsy rules are just a way of figuring out when a non-Boolean is coerced into a Boolean role, then it will be coerced either into being true or into being false. And we call that truthy or falsy. So it turns out that all strings are truthy except our friend the empty string. Turns out that all numbers are truthy except 0. Falsy values are going to be our empty string, 0, null, and undefined. So don't overthink this one too much. It's a weird thing, but as long as you follow these rules, it's pretty straightforward. If this condition is any string, it will be treated as true unless it is the empty string. Then it's treated like false. This condition could be any number. Could be a negative number. But if it's 0, it will be treated as false. And finally, if this condition is null, or if we fail to define it, remember just declaring it and not assigning it is the same as assigning it to undefined. It will be treated as false. So just good things to know. And another interesting thing about this truthy stuff is that if you ever not a truthy value, it's going to turn to false. So if you not a truthy value, it won't turn to a falsy value. It will just literally turn to the Boolean false. So this just, the not symbol is a way to flip it to the opposite Boolean version. On that note, if you ever want to turn a truthy value to just the Boolean true, use the double not symbol, 2 exclamation points. So let me get rid of these for a second. So if we double not the string, instead of getting the string back, we get the value true. If we double knotted null, that would turn it into false. And you'll see a few examples of this on the homework tonight. You can triple knot if you want, but triple knot is literally the same as the single knot. So any odd number knot is going to be the same as just 1, and any even number knot is going to be the same as 2. So you can knot at your leisure, but you're just spinning in circles. You're just on the seesaw of the Boolean world. Why would you want to double knot? If you ever wanted to, I'm trying to think of a good example, but if you needed a Boolean value specifically, if you were writing some bit of code that would fail if that's expecting a Boolean type, you know, there might be there's a little operator called type of. So if we did type of true, we'd get a Boolean. If we did type of a truthy value, we'd get string. If we wanted to change that, we could double knot it. So there might be a situation where type is really important, like in the case of triple equals, and in that case, you'd want to convert it. You use this to convert it to a Boolean. Okay, so yeah, that's kind of a random topic, but that's truthy and falsiness. That's all I want to tell you guys about logic and control flow, but we do have one other topic for tonight, and that is looping. So the if-else statements or conditionals are all about having optional pieces of coding. Loops are kind of the opposite. They're about having repeating bits of code. So if you wanted to count down from 3, or let's count up. And this is your first exposure to the fact that in computer science, we always start counting at 0. So when I count up from 3, I start at 0. So if I wrote this code, it works. We count up to 3, but this is not a good bit of code. This violates, my number one code rule, which is that code should be dry. Dry means don't repeat yourself. So these lines of code are not exactly the same as each other, but they're pretty darn similar, and there's a pattern. So in a case like this, we would want to use a loop. So I'm going to write out the loop that does the same thing as this, and then we'll break down how it works. And this is called a for loop. Okay. So there you go. Same thing, much easier. And if I wanted to count up to 10 instead, I could just change one tiny thing and it works. So how did I accomplish this witchcraft? Let's talk about all the, well, to start, it's not too different from an if statement or an else statement in that we start with a keyword, for in this case, for loop. We have some conditions. In this time, we actually set up 3 conditions. And then we have some curly brackets, which means, what do we call the thing inside the curly brackets? Anyone remember? Block, yes. So we call it a block, not a block, a block, and there is scope. Scope is a thing that exists in here. We'll talk about it in a minute. So we've just created a block of code inside of these curly brackets. So here's how the for loop works. The for loop, the engine behind the for loop is a variable called I. It doesn't actually have to be called I, but it's usually called I, so we're going to call it I. And I is an index. It's a counter. It keeps track of how far we are in our looping process. So we start off by initiating I and giving it a starting point. And we always want to use let for I because I will be changing. So this first expression inside of the conditions is I's starting point. The next thing we do is we check. This check tells us when to quit. As long as it's true, we keep looping. As long as it's not, or if it becomes false, we're done with our loop. So this is kind of step 1. Then we would go to the check. And if the check passes, we move on to the block. So think of this as like the preliminary step. Then we do step 1, check. Step 2 is run the block. And then step 3 is change I. Oops. So the start will only run once, but then we're just going to loop through 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3 until we fail our check. Once we fail our check, we're done. We won't ever get to step 2 on that loop. But every loop is this 3-step process. And it's a little confusing, right? Because you would think it's 1, 2, 3, but it's actually check, block, change. Check, block, change. I'll write I don't want to promise to write a song about this one because I have stuff to do. But maybe I will write a song about check, block, change someday. Okay, so that's how looping works. So let's see what happens here. We start with I at 0. 0 is certainly less than 11. So that means we console log 0. There it is in the console. Now we go up to the change. Do you remember the plus operator from last night? I mentioned it only briefly, but it's going to be important with looping. The plus operator is kind of strange because it actually reassigns I without even using an equal sign. It will, in memory, increment the value of I. So now I is moved up to the value 1. So then we keep on our loop. So back here, 1 is less than 11. Now we're going to console log 1. Increase it to 2. 2 is less than 11, console log 2, increase it to 3. I'm not going to keep going, but hopefully you guys get the picture. So that is how a loop works. And then we keep going, that's me fast forwarding. And then at some point we console log 10, I becomes equal to 11. And then we go over here and we see that this fails. 11 is not less than 11. So at that point, we're done. We quit. So that's how a loop works. A couple other things to mention. Oh, notice that I is available within our block scope. So we can console log I. We could do console log I plus 10 if we wanted, or I times 10. Or if we just wanted to console log the same thing over and over again, we could do that too. We don't have to use I inside of our block. We just often do. And because of scope, what do you think is going to happen when I try to access I outside of the for loop? What do you think is going to happen when I run this code? Undefined, undefined, error. Ah, good job. It is actually error. You guys were kind of both right, because it's error. I is not defined, and not defined is slightly different than undefined. Not defined means it's never even been declared. So we actually get an error. I is not defined because we instantiated I within the block. Technically, this is a subtle point, but technically everything in the parentheses is still part of that same block scope. So there you go. Let's see, just a couple other examples with loops. We don't have to loop up necessarily. We could instead count down. We could start I at 3. If we wanted to, okay, actually, I'll quiz you guys. If we wanted to console log 3, 2, 1, 0, I already gave you the first one. I should start at 3. What should our check be if we want to get there? I see it. As long as I is greater than or equal to 0. If we just did greater than 0, 0 would not be included. And then finally, what do we want for our change step? I minus minus. Cool. There you guys have it. I'm going to make you do one more. This one's slightly trickier. So if I wanted to log, let's say for, I'll start it at 3, 5. There are a couple different right answers here. How would we accomplish this one? Logging 3, 5, 7, 9. What would be our starting point? We'll start at I equals 3. Cool. What about our check? I is less than 11. There are a few different options here. Actually, less than 11 would work. Less than 10 would also work. Less than 10.2 would work, but it would be extremely arbitrary. Let's do less than 11. And then what goes over here in the change step? Ooh, okay, I see 2 different answers out there. So I plus 2 is an answer that's coming out a lot, but this will not work. What just happened? Can anyone explain to me what in the world just happened when I had I plus 2 as my change step? I never changed. Yeah, exactly. So remember that I plus 2 does not have a side effect. I plus 2, it is an operator actually. It adds things together, but it doesn't store anything in memory. So we could do, and because of that, we got an infinite loop. We were forever stuck on 3, and finally Replit caught it and stopped it. So we could do I equals I plus 2. Now we're actually reassigning the value back into I. This would work. Or there's actually a shortcut. We could do I plus equals 2. This is a nifty little shorthand for just incrementing something. There's also a minus equals 2. So if we wanted to do something like that. So you guys, it seems like you are looping experts at this point. So you are ready to roll for the loop homework. Speaking of the homework, one thing I wanted to mention is that something else that's cool about scope is sometimes there are keywords that only work in scope. And it turns out that loops have a continue and a break keyword. So these are 2 different things that you can use inside of your loop scope to do a couple nifty things. The short answer is that continue lets you skip a single iteration. That's like a single 1, 2, 3. Break lets you break out of your loop early if you want to for some reason. I'm not going to go over those in detail. They are on a couple of the stretch problems in the homework. So I just wanted to briefly mention them. And if you want to do those stretch problems, you will have to do some Googling. And just as a reminder with scope, this is fine. But if we tried to do a continue outside of our loop, we get a syntax error. So scope is so powerful that there are actually keywords that are only allowed in certain scopes. So let's go ahead and go over the homework, and then I will answer some questions. I'll try to get you guys out slightly earlier tonight. I know these lessons have been going kind of long. So the first assignment for tonight is all about logic. So you have, it's pretty straightforward in terms of all the questions are the same format. You have some sort of logical statement here, and then we know that true and false is equal to false, right? So you just assign your answer in. So just go through and assign all your answers in, and we start to combine them. Once we get down to the stretch problems, they get pretty convoluted. But this will be a good chance to drill yourself on these logical operators. You want to get comfortable enough with them that you don't have to think about them. One little word of warning on this homework assignment is if you run the tests, you have the answers, right? There is literally only 2 possible answers for all these questions. So I would really recommend not, in every other homework assignment, I recommend continuing to run the test as you go. It's a really good way to check what you're doing. This is the one exception. Really don't run the test until you feel quite sure about your answers. And if you've gotten some wrong, that's fine. You can switch them. Just try and take a minute to realize why they were different. But if you just run the test from the get, if you randomly guess and run the test, you'll be able to know what the right answers are, but you've just learned nothing. So don't do that. The second assignment is all about looping. So the first couple questions are kind of weird. I've given you like the longhand version of how this would work. So I've kind of left out the check step, but we have our start step. This is our the block and then the change. Block and then the change, block and then the change. So it's your job to figure out how to write a loop that does the same thing that this code does up here. Same thing down here. We have the start, the block, the change, the block, the change. It's your job to figure out what loop would do the same thing. So one note on this, and then there are a bunch of other looping questions here. So you will have a chance to use an if-else statement. Ooh, this is a good thing. So if-else statements and loops can actually work together. Let me just show you this over here. So let's say that we're trying to do this example, right, where we logged 3, 5, 7, 9. What we did up here was totally valid, but there's another way we could have done it with plus plus. So can anyone tell me how we could, with this conditions up here, how we could have written our block using an if statement to make this run? We could use a continue. Let's stay away from continue for a while. Yep, so we could do, to get really primitive, we could say if I is equal to 3 or if I is equal to 5. This is not ideal code. Or if I is equal to 7, but a nice chance to practice your ors, or if I is equal to 9. If those things are true, console log. The easier way to do this involves the mod operator. That's this little parenthesis symbol. I'm going to make you guys Google it because you need it for one of the homework assignments. So you'll have to learn about the mod operator. But the point here is that this is such a horrible if condition. The point is that you can have an if and a for loop. You could also have a loop and a for. You could have a if that has a for loop in it that has an if statement in it. Just make sure you're tabbing over for every new scope you create. That will help you keep track of what's going on. And putting if statements in the loops is going to be necessary in the homework tonight. So the last thing to mention on here is there's no testing, but there's really not a necessity to have tests because you can pretty clearly see if your code's working or not based on the console logs. So notice that when you press run, it's the example. It'll show you the logs for the example. So just make sure that the logs for all the questions match to what they called for. So you'll have to kind of manually test it yourself. Shouldn't be too bad. It'll help you see what's going on with your code. So no tests on this one, but check the console log to make sure it's working all right. Okay, so yeah, and I'm pretty sure I saw that the homework had not been released yet. So it'll appear in Replit. If no one else releases it, I'll make sure I release it. But before that, any other questions? I'm going to try and keep the Q&A a little shorter tonight, so I might skip over your question, but I'm going to try to get to the most relevant ones. And try and ask in the Q&A. I do see a question, once again, enabling you guys. Ooh, can I please talk about hoisting? Yay. Not the most relevant, but I promised I would, so I will. Okay, so let me show you two examples. Okay, let's start with this. So what's going to happen when I try and console log a variable that does not exist? Anyone know? Random name, not a variable I've declared anywhere. Error, yes. You'll get a reference error. Random name is not defined. That is the error you get when something has not been defined. What happens if I try and console log my Gerber is my random name. What happens if I try and console log above where I've declared it? So we have some people think it's going to be an error. Some people think it's undefined. Some people think it will be defined. It's actually undefined. And the reason is that this line of code is what's called hoisted. That means it's like preloaded. It's like when you're flying and all the like special people get to get on the plane first. That's like what hoisting is like. So, but yeah. So const random name, this half of the expression is actually going to be pre-read. So at this point, random name has been declared, but it has not been assigned. So the order is actually this runs first, then this line of code runs, and then the assignment runs third. So it turns out that as you're going down the regular flow, only the assignment part is being read because the actual creation of the variable is hoisted to the top. And there's one other example of this that I'll show you on the very last night of this course, a week from tonight. But just a little insight into why JavaScript is not exactly what it seems. So that's hoisting for you. Okay, we want to talk about scope. So local scope versus global variable. So local scope just means whenever we've created a new block, like an if statement, we create a local scope. So this is a local scope. The else statement is a different local scope. If we had a for loop, that would be another local scope. So local scope is kind of a catch-all term that just means anything that's outside of the global scope, anything that's within some sort of new scope that's been created in new curly brackets. And the big takeaway of why you need to keep track of local scope is because anything you create inside here is not available outside. So this is like a controlled, think of this as like a controlled environment, and whatever exists in there cannot get back out. So if we try to grab name down here, it's like it doesn't exist. Well, did I declare it earlier? Let's try something else. Let's try this one. Okay, cool. It's not even undefined. It's actually an error. This line, not a single piece of this line of code was ever registered. So once we're out of our scope, the slate has been wiped clean and everything in the local scope is kaput. All right, any other technical questions? I see one about how can I catch up from being absent for the last 3 days. It might be hard for you to jump in. So if you were absent the last 3 days, watch the video from last night. That will really help you build up from this point. The other 2 videos are important too, but they're on unrelated topics. But in general, just watch the videos, do the homework, and if you want, you can always wait till the next section, which starts in a couple weeks. Okay, yes, I see in chat. Another scope example, what happens in Vegas stays in Vegas. What happens in the F block stays in the F block. Perfect. I'm going to use that from now on. All right. Any other questions? All right. I'm going to take this as a sign that you guys are ready to do some homework. Ooh, okay. One more interesting scope question. Yeah, this is a great question. So what happens if let's say, let new var up here. I don't know why I have an else statement. I'm not using it. That works. So it belongs to the scope where it was defined. So it was declared in global scope. So even though we've assigned it in the block scope, it actually belongs to the global scope. So that is kind of the way around it. If we want to manipulate a variable in our if statement, that's allowed. It's just if we declare it in there that we'll have problems. And yeah, if you use var, the scope issue becomes moot. The scope rule does not apply to var, but that's one of the reasons we don't like var. The scope rule, while maybe a little annoying at first, is nice. It's one of those built-in rules that forces us to be good coders. So stick with const and let. Var is dead. Yes. Var is dead from user. I'm going to spell Nietzsche wrong. I think there's a Z in there. All right. I should not have even tried that. Okay, cool. So, oh yeah, there's someone's showing me how to spell it. I give up. I give up. Time for me to call it quits. I'm making existential philosophy crossover coding jokes. So that's definitely a good time to say we are done for the week. All right. So we are done for the week. That is all I have for you guys this week. We will resume on Monday to talk about functions. Good luck with the homework. I'll stick around for a minute and make sure that's released in Replit if it hasn't been already. As always, Google when you get stuck, ask questions in Slack, and if you need to, reach out to me directly, except I've been getting a lot of messages lately and I'm overwhelmed. So don't reach out to me unless it's important or unless you want to say something nice or talk about David Foster Wallace novels or something like that. But anyways, okay. So that's it. Have a great weekend, and I will see you guys on Monday.